Hello, my bebes. It is Miss Lloyd, and we are looking at trigonometric functions for any angle, any of them. So when we're doing this, some of the important bits we need to remember is one, how to find a hypotenuse. So we're looking at this is an altered version of Pythagorean's theorem, where instead of doing a squared plus b squared equal to c squared, I've taken the square root of the hypotenuse and just have my x and y there. And we're using x and y and that r value in order to find our sine, cosine, tangent, and all of their um, compatriots. I feel like they're the same thing. They kind of mean the same thing, but I don't know right now. I'll figure it out. It'll be all right. Someone can put it in the comments. That would be really helpful. But anyway, we're using SOHCAHTOA, so we're dropping down to the nearest x or going up to the nearest x-axis, creating a right triangle so that we can find the sine, cosine, and tangent using SOHCAHTOA and their reciprocals. And something to keep in mind, whenever we are in the different quadrants, it's going to, each of the sine, cosine, tangents are going to have different signs. So because cosine has to do with x, it's going to be positive when the x values are positive. Because sine has to do with y, it's going to be positive when the y values are positive, negative when the y values are negative. And then tangent, because it's x and y, it's going to be positive when both x and y are positive and when both x and y are negative, because a negative and a negative would give us a positive. So one way that we sometimes remember this, depending on what book you're looking at, is ASTC, so all students take calculus. I don't think that's legitimate though, because not all students take calculus, and just because you don't take calculus doesn't mean anything about you, just that you don't take calculus. So I like to think of it as all street tacos crush it, because street tacos are awesome, and like all tacos are awesome. So like not just street tacos, but street tacos in particular crush it. All of the all of the trig functions are positive in quadrant 1. Only sine is positive in quadrant 2. Only tangent is positive in quadrant 3, and only cosine is positive in quadrant 4, which is all street tacos crush it, to help you remember. And it always goes counterclockwise, just like our unit circle does. So the first one I'm going to go over, we have a point -2, 3, and that is on the terminal side of our angle. So they want us to find just the sine, the cosine, and the tangent of this. So I've kind of set up my y and my x-axis. So -2, 3 would be about here. And so there is my angle theta. See, that terminal side goes right through that 2, 3. And because of that, I can make a right triangle here. So I'm going to drop down to the nearest x-axis. In this case, it's down. And so I know that that is going to be a length of 3 because my y value is 3. Y goes up and down. And then my -2 is going to be my x-axis here. Oops. My -2 is going to be along the x-axis. And I know it's negative because we went left. We are in the second quadrant. So now the last thing that I need is this r value, and then I have everything of my right triangle so that I can use SOHCAHTOA. And I can't simplify square root of 13 anymore, so it's just going to be left square root of 13, and that is my hypotenuse. So now I can use my SOHCAHTOA in order to find my sine, cosine, and tangent. So remember, sine is always our y over our hypotenuse. I don't like that my denominator has a square root in the bottom, so I'm going to rationalize this. If only I could rationalize my life that easy. And I can't simplify this anymore, so there's my sine function. Do the same thing for cosine, but cosine will be x over r. And I have to again rationalize. And I've got my cosine, and then last bit is my tangent, which is going to be my y value over my x. Oh look, something I didn't have to rationalize. And then we're done. Sometimes when we're doing this, we also want to find a reference angle. So if the reference angle is something that we can revert back to maybe the first quadrant, then we can use that. I like to use my trig hand trick to figure out some of our trigonometric functions. So when we're doing our reference angle, we always either drop or go up to the nearest x-axis. And we're going to be finding that distance to the nearest x-axis for that angle. So for this first one, I always like to draw my angle. I'm a very visual person. I know 213 it's past 180, but it's not quite 270, so it's going to be somewhere in my third quadrant. And since I know that my 180 is that negative x-axis there, that I'm trying to find that distance from my 213 to my 180, which means I'm taking 213 degrees and subtracting 180 degrees. And when I do that, I end up with 33 degrees. So this is my reference angle. And we typically use alpha for a reference angle, baby alpha. And I know I probably draw my alphas not entirely correct. My coworker, Mr. Costas, can always educate me on it later if he has the time. Next, when it comes to evaluating trig functions, I personally like to draw out the angle. Figuring out which quadrant you're in is very important, so that you know what's positive versus negative. Finding the reference angle, I find the reference angle because I just use the trig hand trick and I keep everything like associated to that first quadrant. And then I use the hand trick to evaluate. So for this first one, I have 7 pi over 4, so I'm going to draw that out real quick. So 7 pi over 4, 7 is really close to 8. 8 pi over 4 would be 2 pi. So I know that this is going to be in the fourth quadrant. If you've done all these trig functions long enough, then you know that this has a reference of pi over 4. It is a something pi over 4, so it tends to always have that reference. So then if I have 2 pi here, and this is 7 pi over 4, then that means that this here is a distance of pi over 4. It is in the fourth quadrant though, and I have to keep in mind that my sign is going to be negative in the fourth quadrant. So the sign of 7 pi over 4 is going to be the same as the negative version of sine pi over 4. And pi over 4, when I use my trig hand trick, I put down my middle finger. I have 2 fingers off to the right side, which means this is square root 2 over 2. And then we said that this was in the fourth quadrant, so this has to be negative, and then we're done. So this is another example. So with the degrees instead of radians, I'm still going to draw it out. Because this is negative, I know that we're going clockwise instead of counterclockwise, which means that I'm going to be just beyond that 270 mark if I were going positive. And so if I went a little bit further to 180 degrees, negative 180 degrees in this case, that means my reference angle is going to be 60 degrees. So if I have a reference of 60 degrees, and I know that I'm in quadrant 3, I know that my cosine is negative in quadrant 3, so we're looking at negative cosine of 60 degrees. And if I put down my ring finger is my 60-degree finger, to the left of that is just one finger, so then I know that this is going to be equal to 1/2, and it's going to be negative 1/2 because cosine is negative in the third quadrant. Next, they're telling us that our angle is going to be in the third quadrant. Really good to know. And they're telling me that sine is negative 4 over 5. And they want us to find this first one that I'm going to do with you on this video is cosine. And so here they've told me I'm in the third quadrant, so I'm going to draw out the third quadrant a little bit. I'm a visual person, so this really helps me. And then when they've told me sine, that means that they've told me my y value and my hypotenuse. So I know that I've gone down 4 spaces over some amount, not sure. I know that I would have gone over to the left because they said, again, the third quadrant, so I know I would have to go over somewhere this way, which means I'm going up to my 180 degrees x-axis, and I've got negative 4 here along the y, since that is y over r, or my hypotenuse, and I know my hypotenuse is going to be 5 because they told me that in my sign, and now I just need to figure out what the x value is here so that I can find my cosine, which means I need to do the Pythagorean theorem. And so here I figured out that x is equal to 3. Because we had gone over to the left, I know that x is going to be negative 3 in this case. So then now in order to do cosine of my theta, I know that that is x over my r. So I've got negative 3 over 5. That's all that I've got for you guys today. If you found this helpful, please like and subscribe. And if you think this could be helpful for someone else, please feel free to share. Spread the love.